Hi guys, in this video I will show you how to implement an array list. If you're not familiar with an array list yet, please check out my other video in which I explain what an array list is. I put a link in the description below. In this implementation, I do not use templates. I want to keep it very simple and focus just on the concept of an array list. So I will use an array list of integers. The class that I have has three private member variables: a pointer to an array, the size, and the capacity of the array list. I have two constructors, a default constructor and a constructor that expects an initial capacity. Then I have a destructor and two functions, one for getting the size and the other one for getting the capacity of the array list. Then I overload the bracket operator for setting an element at a particular index in the array list or for getting an element by index in the array list. I also have four additional functions: an add function for adding a value, a get function for getting a value by index, a remove function for removing a particular value, and a remove at function that removes a value at a particular index. Let's take a look at the CPP file in which I implement these functions. At the top of the CPP file, I have the two constructors. For the default constructor, I simply call the constructor that expects the initial capacity, and I pass in 10 as the default capacity. For the constructor that takes an initial capacity, I dynamically allocate a new int array with the given capacity. Then I initialize size to 0 and the capacity to the initial capacity. For the destructor, I simply delete the array, and the size and capacity functions return the size and capacity respectively. I overload the square bracket operator that takes in an index, and here I simply return the element in the array at that particular index. Now let's take a closer look at the add function. The add function adds a new value to the array, and there's one edge case where the existing array is full and we have to double the capacity of the array. The condition checks this edge case. It checks if the size of the array equals the capacity. If that is the case, I create a new pointer that points to the existing array. Then I take the current size, multiply it by 2, and assign it to the capacity member variable. That means if the size was currently 10, multiplying the size by 2 would give 20, and the capacity is now 20. That is, I double the capacity in this step. In the next line, I dynamically allocate a new integer array of the new capacity, and I assign that array to the array member variable. So array now points to the new array that is currently still empty. The old pointer gives me access to the previous array that still holds the elements. As a next step, I have to copy the values from the old array to the new array. So here I start at index 0, I less than size. Note that I only updated the capacity to twice the size. The size is still the size as it was before. So if the size was 10, size is still 10, but capacity doubled to 20. And in each iteration, I increment I by 1. Then I copy each element at index I from the old array to the new array. At the end of the loop, array will be half full, and the other half will still be empty. That is again because if, for example, the old array was filled up and it had 10 elements, the new array would be allocated with 20 elements, and the old 10 elements were copied over to the new array. So the new array now has 10 elements, but it has a capacity of 20. The final step for the edge case is to delete the old array and free up the memory. This is what I'm doing here. Now the next two lines add the value to the array. This happens regardless if the edge case is executed or not. In this case, I go to the array at index size. So I use size as an offset. Take the example where size is 2. Size can also be used to indicate the next free spot in the array. If size is 2, there are 2 elements in the array, and these elements would be stored at index 0 and at index 1. So 2 would be the next free spot in the array. So I go to that spot by going to array, which points to the very beginning of the array, plus 2, would then go to the next free spot. I set the value at the next free spot, and then I increment size by 1. So I use size as the size, but I also use it as an index to the next tree spot. The next function is getting an element by index. Here I go to the array and then I take the index as an offset. I use pointer syntax, but you might as well use array syntax. The remove function removes the given value from the array list. It only removes the very first encountered value from the list. I start at index 0, less than the size, and then I compare each element in the array to the given value. If the element in the array equals the value, then I remove the value at that index and I return it. So this only removes the very first match in the array. Let's take a look at the remove add function. Now remove add removes a value from the array list, but I also have to be sure that I shift the values to the left whenever I remove a value. The initial condition here checks if it's an invalid index. If the index is less than 0, or if the index is larger or equal to the size, there's nothing to remove and I return false. Otherwise, I remove the value from the array list. Let's take an example where index is 1. So if index is 1, I would want to remove 34 from the array. I can remove 34 by shifting 27 to 34, 83 to 27, and 25 to 83, and then setting 25 to 0 and decrementing the size. So in this case, if this would be the array, the index of elements would be from 0 to 4, size would be 5. In the loop, I initialize I to index plus 1. So again, if index is 1, I would be initialized to 2. And then as long as I is less than the size, I increment I by 1. I get the current index, which is I minus 1. So in the first iteration, cur would be 1. I would be 2. Then I set array at cur, so this would be 34 here, to array plus I. Array plus I would be 27. So basically I assign 27 to 34. Then I increment I, so I is now 3. Cur would be I minus 1, so it would be 2. And then again I assign 83 to the element at index 2. Then I increment I would now be 4. Cur would be I minus 1, which is 3. Then I take array at index I, which is 25, and assign it to array plus cur. So this puts 25 here. Then I increment I again. I is now 5, so 5 equals the size. This condition is now false and it stops the loop. Next, what I do is I decrement size by 1. So size would then be 4. Then I access array at the decremented size, which is 4. So this would be here. And I assign 0 to it. So this clears it. And now size also still points to index 4. So when I call add again, it would put the new value at this position. And if I get the size, I correctly get that there are 4 elements in the array list. And finally, I return true that the remove operation was successful. Now let's take a look at the main function where I use this array list. So initially, I create an object of the array list. Then I print out the size and the capacity. If I go to the print function, you can see I simply have a cout statement. I output the size followed by the capacity. The next line, I'll add 5 to the array list. And then I print out again the size and the capacity. Now in the next lines, I add values 11 to 20. So I start at index 1 all the way to 10 and including 10. And then I add 10 plus I. So initially it would be 11 and then all the way up to 20. And after this loop, I print out size and capacity again. Note that in this case, I use the default constructor. So the initial capacity was 10. And by adding 5 and 10 additional values, I want to find the edge case where it should double the capacity to accommodate the 11th element. Then I use the sect function using the square bracket operator. So I set 99 at index 2. And then I use a loop to iterate over the array list. Again, I use the square bracket operator to access the element at index I, and I output it. Now let's see when I run this program. You can see here, initially the capacity was 10 because I used the default constructor. The size was 0. I haven't added any elements to the array list yet. Then I add 5. This makes the size 1, capacity is still 10. And then I add 10 more values. This increases the size to 11 and capacity doubled from 10 to 20. Then I set the value 99 at index 2. You can see index 2 changed from 12 to 99. And then in the final loop, I just iterate over the array list and output the values 5, 11, 99, and then 13 all the way to 20. I hope you enjoyed this video. Thank you for watching.